So when you go to start a proof, it will have information that's given to you, and it will tell you what you have to prove. Okay, so right over here, it is given to me that angle 1 is supplementary to angle 3, angle 2 is supplementary to angle 3. That's my given. It literally says the word given right there. So we're going to write angle 1 is supplementary to angle 3, angle 2 is supplementary to angle 3, and our reason is given. Excuse me. Now, I was asking you to come up with what you know by reading that the two angles are supplementary. What do you know because these are supplementary? What do you know, Rachel? They add up to equal 180. Their measurements do. So we take that and we write that as measurement angle 1 plus measurement angle 3 equals 180 degrees. And we can go ahead and say that measurement angle 2 plus measurement angle 3 equals 180 degrees. And our reason? Definition of supplementary angles. So that's what you were doing in your assignment last night, is just taking information and coming up with what your next step could possibly be. Now here's where it gets a little tricky, is you have to, in the back of your mind, be thinking, I eventually need to have angle 1 on one side of an equal sign and angle 2 on the other side. That's where I need to get to. Currently, I have angle 1 and angle 2 in two separate equations. I need to somehow take this information and make one equation. So I'm going to pause this video, and I don't know if anybody will come up with it. But I'm going to give you a moment to see if you could think of any way that we could take these two equations and combine them into one equation, one equal sign, so that we can eventually get angle 1 and angle 2 somehow in the same equation. Okay? So talk with your group and see if there's a way you could possibly use step 2 to make step 3. So what I was trying to have you do is think about how we could get 1 on one side and angle 2 on the other. Right here we have angle 1 and angle 2 in separate equations. But if I add 1 and 3, we get 180. If we add 2 and 3, we also get 180. That means that these two sections, these two parts of the equal signs, they have to be equal to each other, because they both equal 180. And that is the transitive property. That's when you have two separate equations and you can combine them into one equation because they're both equal to the same thing. That's the transitive property. Okay, now we're trying to get just angle 1 and angle 2 on equal sides by themselves. Look what's happening now. What could we do next? We can subtract measure of angle 3 from both sides, because measure of angle 3 is on both sides. What property allows us? No. Subtraction property of equality. The subtraction property of equality allows us to subtract the same thing from both sides of the equation. And when we do that, we have measure of angle 1 equals measure of angle 2. Is that what I'm trying to prove? Almost. The answer is not correct. I mean, it's not what we're trying to prove, but almost. How? If they are, if their measurements are equal, aren't they congruent now?
Yes.
So I can go and say angle 1 is congruent to angle 2, but why am I allowed to go from step 4 to step 5? Definition of congruent angles. Definition of congruent angles. And we did it! Yes! Turn the page! Oh, wait, don't turn the page. What we did just now is we just proved the congruent supplement theorem. So some of you wanted to already use that. It's right up here. It says if two angles are supplementary to the same angle, then they are congruent to each other. In order to be able to use this, we have to prove it. Proved the congruent supplements theorem. That's what we just did. So today we're proving some of these theorems. There are more theorems up here, which I haven't talked to you about yet. You're going to use into your vocab sheet, and we're going to keep talking about them. Excuse me. If they're not in there, then you just add them to the end. I gave you extras. At the end, there's extras. All the way to the back page. Okay. And if we run out of pages, then we'll just add more. Where was I? Deductive reasoning. That's what we're doing right now. That's what we're doing with these proofs, is you're using facts, you're using definitions, properties. You're using these things to find theorems. That's what we're doing. A theorem is a statement that can be proven, where postulates that we were talking about before are just statements that are accepted. And a proof is a logical argument that uses deductive reasoning to show that the statement is true. So we just went through proving congruent supplements theorem. Okay? Now let's look at, I'm skipping. Let's look at prove the right angle congruence theorem. So there's another one where I'm going to ask you guys to work as a team and see how far you can get. I'm going to put a team and see how far you can get. Okay. So the first thing that you guys did was you wrote down angle 1 and angle 2 are right angles because given. And then from there, a lot of you had no problems figuring this out. Measurement of angle 1 equals 90 degrees. Measurement of angle 2 equals 90 degrees. Because why? Definition of right angles. That's what told us whenever you learned, I don't even know when you guys learned it, 3rd grade maybe, what a right angle is. Oh, it's an angle that measures 90 degrees. That's when you learned that maybe. I don't know. 2nd grade? When do you learn that? I know that my son knows it, but I don't know if my daughter knows it, so I'm thinking 2nd grade, 3rd grade. Okay. What? Well, he's in 5th grade math, and I know he knows it, but my daughter's in 2nd grade. I don't think she knows this, so somewhere. 5th grade? Learning stuff than you did. Okay, so from here, if measure of angle 1 equals 90 and measure of angle 2 equals 90, then measure of angle 1 has to equal measure of angle 2 by what? Transitive. And if we're almost to what we need to prove at this point, I can say angle 1 is congruent to angle 2 by definition of congruent angles. Done. The next one we are doing is example 4. We're skipping it right now. Next we are doing is example 4.
In the vocab packet, you had it down as just proof. Is that the same thing as 2 columns? Okay. In the vocab packet, it says 2 columns.
Oh. It's the same thing. It's just it's going to be the same thing except using the words like first column is our step, second column is our reasons. Okay, so we're going to write down our given. And we're going to look at what we have to prove. And you guys, this one I'm going to ask for kind of some group participation. We're trying to prove that segment AC is congruent to segment DE. This is not given to us. That's what we're trying to prove. So what we have to do is we have to start thinking about how we can possibly get AC and CE in here. Right now I'm given that AB equals DE and BC equals CD. But I need to start thinking about how I can possibly get an AC and a CE somewhere in here. Is there any way that I could get AC by looking at this diagram, that I could write something that has AC in it? That we've done? Hayden? It's exactly what I was thinking. AB plus BC equals AC. Why was Hayden allowed to say that? Segment, addition, postulate. And while we're doing that, is there another segment addition postulate thing we could write down, Zachary? I'm trying to get CE, Zachary. And I'm going to use the segment addition postulate. I'm trying to get CE. How can I get CE? And Austin, you guys are a team. Two of you together. How can I get CE?
CD plus DE.
Yeah. CD plus DE equals CE. Which one of you answered? I wasn't looking. That was Austin. Okay. Good job, Austin. Okay, so this next one, I don't know that you'd be able to come up with this next part. So I'm totally walking you through the next part. I'm going to try to use some colors to help you understand what I'm doing. So what I'm doing is I'm trying to get AC and CE to be equal to each other. I'm trying to get them equal to each other. But at this moment, AB and BC and CD and DE aren't the same. So I can't use the transitive property like we've been doing. But I am trying to get AC and CE equal to each other. So I'm going to get these two sides, AB and BC, CD and DE. I'm going to get them to look exactly the same. I'm going to use that AB equals DE. I'm going to use this right here, and I'm going to remove AB from this equation. If I remove AB from that equation, what would I put in its spot? DE. So I'll have DE plus BC equals AC. What allows me to take something out and put something in that is the exact same thing? Substitution property. Now, DE plus BC is not what CE equals, so I'm going to do something to CE also. I'm going to take BC equals CD, and I'm going to take out CD. Take out CD. What should I put in its place? BC plus DE equals CE. And that's still substitution. Am I closer? Let's see. Do these sides look like they're the same? They're almost the same, aren't they? How are they not quite the same, but they're almost the same? The order? Okay, guess what? We have a property on that theorem sheet, that property sheet, that allows, it's not symmetric though. I know you want to say it. I know you want to say it. It's something else. There's something that allows us to take the order. I'm just going to do it to this equation here. I'm going to take that equation and rewrite plus DE equals AC. So I just took this equation and I reordered it. Now, this would be a property we have not talked about this year, but you should have talked about in the past. So the symmetric is when you switch it around the equal sign. I did not switch it around the equal sign. This is where I'm taking addition, and I know that if I add two things, I can add them in any order, and I can still add them. So this is called the commutative property. You should have learned it in a previous course. Commutative property. And then it's of addition. But I would just write commutative property, but there is a separate commutative property of multiplication. So it's a commutative property of addition. Does that like ring any bell? Have you ever heard of that? Now, you didn't memorize any of it, but but the commutative property, when I used to teach Algebra 1 and I would teach this, I would always say it's like you're commuting, you're going back and forth. But I wanted to make sure I hit that today because one of your questions in today's assignment has that in there, so I wanted to make sure I went over it. Okay, so now can you tell me that this equation and this equation, we can use a property to tell me that AC equals CE? Can we do the same on the other side?
Yep.
Okay, so AC equals CE, so why? Yeah, say it again, louder. Transitive. That property is out. So if BC plus DE equals CE, and BC plus DE also equals AC, then AC has to equal CE. Transitive property. And then what are we trying to prove? We're trying to prove that segment AC is congruent to segment CE. We're trying to prove that. Can we prove it? By what? Definition of congruent segments. Yep. Right. Definition of congruent segments. So, what you're going to do for your assignment is this question right above it that we skipped. I did not give you any steps or reasons. You're going to try that one. The rest of them, I gave you either steps or reasons. And any of the rest of them from scratch. You're going to look and like, you know, if this one does this, how did they get it? Or for this one here, what is the given? Like, you're going to fill in the blank for the rest of the assignment. It's just that one on that one page you have to do from scratch. So I would suggest in the next 6.5 minutes, you do example 3 together while you still have a team to work with. And then finish this packet for your assignment.
For our vocab, for the question symmetric